Hey, this is a video for 9.3, the greenhouse effect. So go ahead and check out the overview and set up your guided notes. So the greenhouse effect got its name because a greenhouse has a glass roof and allows solar energy in, but the heat gets also trapped inside. So in this diagram, solar radiation or light will be represented by orange, and infrared radiation or heat will be represented by green. So we have the solar energy entering the Earth's atmosphere and hitting the Earth's surface and the clouds. Some of that radiation or that light will be reflected back into space from the clouds and from the surface of the Earth. Remember that albedo refers to the reflectivity of a surface. So areas on Earth that have high albedo will reflect a lot of that solar energy, the solar radiation, back to the atmosphere or into space. Now, some of the solar radiation will be absorbed by the clouds as heat, and some will be absorbed by the Earth's surface as heat. This will cause some temperature increase in the particles in the cloud and then the molecules or atoms in the Earth's surface. Now, some of this heat will be emitted back to space, but some of the heat will be emitted back to the Earth's surface. Now, that will be re-radiated throughout the Earth's surface through convection currents, and it will be re-radiated to other parts where it can then be re-radiated back from the surface. You've probably felt this on summer days. When it's, especially after it rains, like you'll feel like just the heat from the pavement. That's the heat re-radiating back into space. However, that gets trapped by the greenhouse gases. So gases like carbon dioxide, methane, chlorofluorocarbons, nitrous oxide, those are all greenhouse gases. Also water. Now, some of them, it's going to absorb that heat energy. Some will be emitted back to the atmosphere, but some will be emitted back to the Earth. So the problem is all of this infrared radiation being reabsorbed and re-radiated back to the Earth's surface. And this is a cycle that just keeps happening. So it's going to then transfer that heat, re-radiate it, and it's going to be a cycle, and the heat will continue to build up. Now, the solar energy is always entering, so we don't really need a lot of greenhouse gases holding this heat in, because the Earth's system has been going for millions of years, and we have actually altered it by adding all of the greenhouse gases. One greenhouse gas in particular, in fact the one we talk about the most, is carbon dioxide. Most of it's coming from fossil fuel combustion. It can also come from deforestation. Now, deforestation prevents the trees from taking in the carbon dioxide, but also the stumps that are left behind will decompose, adding more carbon dioxide to the atmosphere. We also have decomposition of organic material, and a small amount does come from volcanoes. Now, carbon dioxide has a warming potential. I'll talk about it in a minute. It has a warming potential of 1, and this is an arbitrary number that scientists have established. But one that is more damaging is methane. And methane comes from natural gas extraction, especially from fracking and from petroleum or mining for petroleum. Can also come, another major source is animal agriculture, especially cows, because cows belch and fart and they have methane building up. We also have anaerobic decomposition. So technically, all of these images are showing anaerobic decomposition. Inside the cow's gut, inside the termite's gut, they cannot digest the materials that they are eating. And anaerobic decomposition occurs because bacteria are breaking down these organic material, the grass or the wood. They're breaking it down in the guts of these animals, and in the absence of oxygen, methane is a byproduct. We also have anaerobic decomposition in wastewater treatment, in landfills. We also have anaerobic decomposition is coming from melting of permafrost and also from the agriculture raising of rice in rice paddies. So rice is raised also in anaerobic conditions, releasing methane. Now, nitrous oxide is a natural component of the nitrogen cycle. It's also released and it's exacerbated by agriculture. When we add nitrogen fertilizers, the denitrification, when it's being converted back into atmospheric nitrogen, for part of that, it is converted into nitrous oxide. So the more nitrogen fertilizers that we are adding, the more nitrous oxide is released into the atmosphere. And a lot of it will convert to nitrogen gas. However, not all of it will convert. So some of that will remain in the atmosphere where it is a greenhouse gas. Another one, we've talked about this, is tropospheric ozone is also a greenhouse gas. And it's a secondary pollutant, remember that. Also a criteria air pollutant from automobile combustion. And it is formed from nitrous oxides reacting with volatile organic compounds, or VOCs, in the presence of sunlight. We also have completely anthropogenic molecules, CFCs, HCFCs, and HFCs, and they're found in refrigerants and propellants. And not so much propellants anymore, but it's still found in some refrigerants, although CFCs have been pretty much phased out. But we still have some HFCs being produced. And finally, this is one that you might not think about, water vapor. Water vapor is a major greenhouse gas, and it comes from evapotranspiration, evaporation of water, and also transpiration, which is the evaporation of water from leaves of a plant. However, water vapor is not considered a damaging greenhouse gas, and I'll tell you why in a second. But you've probably noticed the warming effect that water vapor has, especially on a hot summer day after it rains. If it's, was really sunny, and then you have just a flash rainstorm, and then the sun comes out again, you can feel that water evaporating, that steam it just feels much, much warmer after it might rain. And that's the absorbing capabilities of the water vapor. It can absorb a lot of that infrared radiation. So we classify these greenhouse gases by their global warming potential. And if you notice, carbon dioxide is like the gold standard. It's the baseline. And methane, you'll either see 24 or 25 times worse. Nitrous oxide, has a much higher warming potential. And you'll notice that CFCs and HFCs are even higher. But we don't just consider their warming potential. That's because they can absorb infrared radiation, and we basically are determining how well it absorbs heat. But we also have to calculate the residence time. In other words, how long it remains in the atmosphere. So methane can stay in the atmosphere for 12 years, which is why it has a much higher warming potential. But nitrous oxide can stay in the atmosphere for over 100 years. And CFCs and HFCs can be in the atmosphere for up to 500 years. Now, just to compare, water is, it does have a lot of warming potential, but it's not considered to be a greenhouse or a major greenhouse gas, globally speaking, because it only has a residence time of around 9 days. So the water cycle is very fast moving and fast acting. So if it gets into the atmosphere, it will fall back down again as precipitation. So what I would like you to do is respond to this check for understanding. And for FRQ practice, I want you to explain why water vapor is not a major contributor to global warming. I hope that this video is informative. I thank you for your attention, and I'll see you soon.